Only 1 to 3% of gold exploration targets ever make it to drilling. The rest, years of fieldwork, millions in funding, lead to nothing. And even when a viable deposit is struck, making gold means crushing tons of ore to particles finer than a human hair, then pushing it through a chemical gauntlet that ends at 99.99% purity. It all begins with signals no one can see. From high above, the search for gold starts with a sweep of sensors, magnetics, LiDAR, and multispectral scanners. These tools scan vast, empty stretches of Earth, capturing shifts in magnetism and subtle changes in vegetation. What looks like a blank patch of ground on a satellite image might glow with promise on an anomaly map. Geologists pore over these digital layers, hunting for the faint fingerprints of buried gold systems, patterns in the data that hint at faults, ancient riverbeds, or mineral-rich intrusions. On foot, teams grid the land with soil sampling. Sometimes hundreds of tiny flags mark where each sample is pulled. In the field, a geologist scoops soil into a bag, labels it, and sends it off for BL-EG assays. These tests measure gold content down to parts per billion, revealing chemical halos that satellites cannot see. When a soil grid lights up with gold and arsenic, it means the data has found something worth chasing. Only a sliver of these targets, just 1 to 3%, ever make it to the next round, which is drilling. Most disappear under closer scrutiny, their signals too weak or scattered. The process is relentless. Each new anomaly demands permits, environmental checks, and community talks before a drill even arrives. The odds are long, but as one field geologist puts it, we're looking for that assay that spikes above the noise. If it's real, you know it in your gut. The search for gold is a science of patience and pattern recognition, where invisible clues must add up before a single hole is sunk. Dawn breaks over the pit, and engines roar to life. At the heart of an open-pit gold mine, shovels the size of small houses scoop up shattered rock, each pass loading nearly 80 tons into a 330-ton haul truck. These trucks rumble up winding roads, their tires taller than a grown man, carrying ore to the plant gates around the clock. The operation is relentless. A single mine can move hundreds of thousands of tons in a day, chasing grades that sometimes hover just above 5 grams of gold per ton. Underground, the world shrinks. Miners work narrow stopes, sometimes no wider than a man's shoulders, drilling and blasting veins that snake deep beneath the surface. Here, only the richest ore, often above 5 grams per ton, justifies the effort. A mine operations manager leans against a haul truck, mud on his boots, and sums up the scale. He says that they move nearly 1 million tons a month. Every load counts. Far from the machine noise, a different rhythm unfolds beside a river. An artisanal miner kneels at the water's edge, feeding gravel into a wooden sluice. The flow of water and a practiced shake separate heavy gold from lighter sand. It is slow, physical work. A day's effort might yield enough dust to fill a thimble. The miner's voice carries over the river. He says that some days you find nothing, but one good pan can feed your family. From the thunder of earth movers to the quiet patience of hand sluicing, gold extraction spans a world of contrasts. Both paths converge at the plant gate, where broken rock, whether by the truckload or by the bucket, waits for the next transformation. Ore arrives at the plant as a mountain of broken rock, but the gold inside is still locked tight. The first step is brute force. A primary crusher chews through boulders, reducing them to fist-sized chunks. These drop onto conveyor belts, feeding a semi-autogenous grinding mill called a SAG mill. It is a steel cylinder as long as a city bus, spinning day and night. Inside, steel balls and the ore itself can tumble together, grinding the rock down until most of it is finer than 75 microns, about the width of a human hair. This precise grind is crucial. Too coarse, and gold stays trapped. Too fine, and recovery drops. Operators monitor cyclone separators, tweaking water flow and mill speed to keep the size just right. As the slurry pours from the mill, it splits. About 12% of the gold, mostly in coarse, free particles, is heavy enough to be caught by gravity concentrators, spinning bowls, or shaking tables that separate gold from lighter rock, producing a small but rich concentrate. The rest of the slurry, still loaded with microscopic gold, moves to flotation tanks. Here, a cocktail of reagents, collectors, frothers, and modifiers binds gold-bearing minerals to air bubbles. The bubbles rise, carrying gold to the surface as a froth, which is skimmed off as a high-grade concentrate. At the heart of this process is the mill metallurgist, adjusting reagents and grind targets on the fly. In their hands, tons of dull gray slurry are transformed into a dense, shimmering concentrate. Just a fraction of the original mass, but now loaded with gold. This is the first real glimpse of the metal's value, and the first step toward true separation from the earth. Gold's journey from concentrate to bullion is an exercise in chemistry and precision. In the heap leach fields, low-grade ore is stacked in towering pads and sprayed with a dilute cyanide solution. Over weeks, the leachate trickles down, dissolving gold into a pregnant solution. This liquid, now carrying the precious metal in parts per million, is pumped away for recovery. Heap leach operations typically recover between 70 and 80% of the gold in the ore, an impressive figure for such a simple setup, but not the highest on the purity ladder. For higher-grade material, the process steps up. In carbon-in-leach (CIL) circuits, finely ground ore is mixed with cyanide and activated carbon. Gold ions latch onto the carbon particles, which are then separated and stripped in a caustic bath. CIL plants routinely achieve 85 to 95% recovery, squeezing nearly every atom of gold from the slurry. The metallurgist checks the readings, watching as recovery inches toward the upper end of the scale. The next act is smelting. The gold-laden carbon or precipitate is fed into a furnace, reaching temperatures above 1,200 degrees Celsius. Flames roar as fluxes draw off impurities, and a stream of molten metal flows into molds. This first pour produces door bars, rough, heavy ingots that shine with promise but still contain silver and traces of copper. Door typically ranges from 70 to 90% gold, depending on the ore and process route. Refining brings the final transformation. The Miller process injects chlorine gas through molten door, separating out silver and base metals and boosting purity to about 99.5%. For the ultimate finish, the Wohlwill process takes over. Door is cast as an anode, submerged in a bath of chloroauric acid, and electrified. Pure gold plates out onto the cathode, reaching 99.99% purity, what the industry calls 4 nines. The metallurgist lifts the final bar, its surface flawless, and reads off the assay, 24 karat, 99.99%. From heap leach to electrolytic cell, each step is a rung on the ladder to absolute purity, and the moment molten gold pours into the mold marks the culmination of this transformation. The gold bar, fresh from the refinery, is far from ready for a jeweler's workbench. Pure gold, 24 karat or 99.99%, is beautiful but soft, too malleable for daily wear. To create something durable, the jeweler must turn to the art and science of alloying. A measured scoop of copper, a dash of silver, or even a hint of palladium is weighed and added to the crucible. The math is precise. 18 karat gold means 75% gold, the rest, a carefully chosen blend. Once melted and stirred, the glowing alloy is poured into a mold, forming a rough ingot. Still hot, it is passed through rollers, squeezed thinner and thinner, then drawn into wire or hammered into sheet. The jeweler's hands guide every step, feeling for just the right yield, soft enough to shape, hard enough to last. The color, the carat, the very feel of the gold is set here, long before a ring or bracelet takes form. Every batch is a quiet equation, balancing purity, strength, and beauty, all coded in the numbers stamped on the final piece. A finished gold piece, whether a ring or a bullion bar, is never truly complete until it bears a hallmark. At the assay office, each batch faces a final test. Technicians sample the metal, running it through fire assay or X-ray fluorescence to verify its purity, down to a fraction of a percent. Only when the results match the declared fineness, like 750 for 18 karat or 999 for pure gold, does the item earn the right to be stamped. The hallmark is more than a legal requirement. For centuries, these tiny marks, lions, crowns, numbers, have stood for trust. In London, the Goldsmiths Company has stamped its mark since 1300. In India, the Bureau of Indian Standards logo and a QR code now link each piece to a digital record. Across cultures, the hallmark reassures buyers this gold is exactly what it claims to be. From the vaults of the London bullion market to a neighborhood jeweler, certified gold travels through wholesalers, retailers, and sometimes auction houses. Each step depends on that stamp. As one jeweler puts it, people see the mark and know the gold story. Without it, there is no trust. Every gram of gold comes at the cost of mountains moved and energy spent. Today, demand climbs higher than ever, fueling both innovation and controversy. Gold's allure endures, shaping markets and ambitions. Its true value? That's still a question only the future can answer. What's your take?